if it's beer, I don't like beer.
All right, guys, I wanted to
I'm
leave
a
like
shot
10 minutes
drinker.
ago. Let's limit the alcohol conversation because I'm sitting here thinking about heading over. Anyway, just kidding. Just kidding.
It's a Monday.
It's a month, yeah, bar times on Mondays are acceptable anytime, right?
Well, at least it's a birthday Monday.
Yeah.
Take the claw.
No. I did not do claw like that.
I don't want to do mine. Like my
It's
cats.
bad for that.
Oh,
Yeah,
destroy all the bank.
You can go to the vet and they'll put on like little tips, like plastic
You can
caps.
get them at the pet store.
I don't know that they stay. Do they stay
They do.
on?
They stay.
They do?
Yeah, they stay. I put them on my pet because it's really bad for them to decompress. It affects their behavior a lot. Yeah, it's just It's
I
also
think
just painful.
by
Like
scratching
it's
they release their anxiety or not.
give them a really good
Stress
scratching
or-
post. A good cat treat.
I don't do cats, but I
Do
will
you have a
say.
cat tree? Those are great.
Get like a scratching post cat treat.
I bought one. He doesn't do that.
He doesn't?
destroys all my
Oh.
That's funny.
Thank you.
Did you post this PowerPoint?
Which one?
This one?
No, this is actually the last one. Just I added this slide.
How's your weekend?
Fine. That was away.
Oh.
Had a flash.
Girl!
Good. Live your best life.
Be one of them.
Sore though.
Almost midterm.
I'm saying that just makes me so happy the semester's almost over. Halfway there already. I'm ready to be out of this school and on to the next one.
Oh, this is your last semester.
Gold Farb next fall. Yeah.
Your last semester.
There's one more to go.
One more year.
Microbiology next semester. You asked me what I'm taking next semester, and I have like 4 classes, but all I would tell you is micro. Like that's all I care about. I'm taking micro next semester. I'm done.
It is overhyped and it sucks.
Okay, everybody.
Do not take it with the group.
So we are talking about the respiratory system, right? So today we'll continue to talk about the respiratory system. Today we will see the differences between right and left lungs. We'll talk about the anatomy and physiology of the lungs.
Bless you.
You know that lungs are the main organs of your respiratory system, right?
Yes.
And you have 2 lungs, right and left. Where gas exchange between the blood and alveoli of the lung takes place, right? So gas exchange is the main function of your lungs, right? We'll talk about the covering of the lung. You remember your heart is covered by connective tissue membrane, right? That is called pericardium. Similarly, your lungs are covered by connective tissue membrane, and that membrane is called, are you okay?
Yeah, I was really cold now.
It's okay. Okay, so that covering of your lung is called pleura. So we'll see the structure of a pleura. Then we'll talk about the mechanisms of respiration or breathing. So you know that respiration has 2 events, inspiration or inhalation and expiration or exhalation. So we'll see how inhalation and exhalation take place. Okay? Then we'll talk about a very important fluid that is secreted in the lung, that is called surfactant. What important role the surfactant plays, we'll see that. Okay, so those are the things we'll go over today. First, if you see a lung has a pointed upper end that is called the apex, pointed upper end of the lung. And so this is a lung, and this pointed upper end is called the apex. Okay? And this bottom part is called the base of the lung. And under the base of the lung, you have a flat muscle. This flat muscle is called what? Diaphragm. Okay? So we can say that lungs sits on the diaphragm. Okay? And in the medial side of the lung, there is an area through which the primary or main bronchus enters into the lung. You already know from last lecture that lower end of trachea is divided into two main or primary bronchi, right? Remember that? So the bronchus enters into the lung through this area. This area is called hilum of the lung. Okay? Hilum is the area, indentation through which the primary or main bronchus enters into the lung, as well as blood vessels and nerves enter into the lung through the hilum. Okay? The right and left lungs are different. How they are different? If you see the picture here, in the right lung, there are two, this is right lung here. In right lung, there are two cups or splits, horizontal and oblique. That means the right lung is divided into three lobes by those two cups. Okay, these are called fissures. Horizontal fissure, also called transverse fissure, and oblique fissure. Okay, so three lobes: superior lobe, middle lobe, inferior lobe. Okay, left lung has only one. You see the picture here. Only one, right? So that is the oblique fissure. So it is divided into two lobes, superior lobe and inferior lobe. There is no middle lobe. Make sense? So in right lung, you have how many lobes? Three. How many fissures? Two. And in left lung, how many fissures? One. That means how many lobes? Two lobes. Okay. So middle lobe is missing. Now, in the left lung, there is a notch like this here, U-shaped area. You remember when you studied the bones, remember the notch? If you see an U-shaped area like this, that is a notch, right? So in the left lung, there is a notch that is called the cardiac notch here. Why this area is called cardiac notch? Because heart, you know, heart is mostly in the left or right side of the body? Left side, right? So to accommodate heart, there, that notch, when the lung develops, a notch is created there. Because the part of heart you see in this picture, heart is here, most part of it is in the left side, 2/3 part of the heart is in the left side, 1/3 in the right side. That's why there is a notch here. That's why that notch is called the cardiac notch. Okay, cardiac refers to heart. Another difference between right and left lung is right lung is broad and short, shorter and broader or wider than the left lung. Left lung is long and narrow. Now see here, why left lung is narrow? Because heart, most part of the heart is in the left side. So that heart, when heart grows, during the growth of the body, right? When the heart grows, it occupies some space. and pushes the left lung and makes it narrow. Does it make sense? So to give some room to your heart, your left lung gets narrower. So those are the important differences between the right and left lungs. Okay, if I ask you in your exam, tell me a few differences between right and left lungs, what will be the answer? First, let's see. Two fissures in
Right
right.
lung.
That means how many lobes?
3.
In left lung, how many fissures?
1.
That means how many lobes?
2.
2. Right lung is broad and
Wide.
short. Left is
Narrow.
narrow and long, right? And cardiac notch is present in
Left.
the left, but absent in the right, right? So those are the anatomical differences between the right and left lungs. Okay. Blood supply to the lung. Two types of blood goes to the lung. You know that all body organs, everybody, all body organs need what? Oxygen, right? And nutrition. And oxygen and nutrition is given to the body organs by systemic or pulmonary? Systemic circulation, right? So, like other organs of your body, your lungs also get oxygen and nutrition from systemic circulation. Makes sense, right? Because lung tissue needs oxygen and nutrition, like other tissues of the body. So, that is one type of blood, oxygenated and nutrition-rich blood, right? Goes to the lung. That is one type of blood. Also, all of you already know that heart sends the blood to the lung to get oxygen, right? Blood goes from the heart to the lung to get oxygen. So what kind of blood goes to the lung from the heart? Deoxygenated, right? So you see, both oxygenated and deoxygenated blood goes to the lung, right? Oxygenated blood to give oxygen to the tissue and nutrition to the tissue, and deoxygenated to get oxygen from the lung, because we know that gas exchange takes place in the lung, right? We know that. So blood goes to the lung to get the oxygen, that is a part of pulmonary circulation, and blood goes to give oxygen to the tissue of the lung, that is bronchial circulation. So two types of circulation, one is pulmonary circulation and another is bronchial, which is systemic circulation. Okay, so pulmonary circulation, blood, deoxygenated blood goes to the lung to get the oxygen. Okay, and bronchial or systemic circulation, blood goes to the lung to give oxygen and nutrition, okay, to the lung tissue. Okay, so that's why you have two types of circulation in the lung. Now you know that in case of pulmonary circulation, pulmonary arteries, right, take deoxygenated blood to the lung, right? Pulmonary arteries take deoxygenated blood to the lung, and veins bring oxygenated blood back to the heart. So that is pulmonary. Arteries and veins. Arteries take deoxygenated blood, right, to the lung, and veins bring oxygenated blood to back to the heart. We know that in case of pulmonary, it is opposite. Arteries carry deoxygenated, veins carry what? Oxygenated blood. You know that. Okay. Bronchial or systemic circulation, we have bronchial arteries, and bronchial veins. this is systemic circulation. So arteries carry oxygen-rich blood or oxygenated blood, and veins carry deoxygenated or carbon dioxide-rich blood. Okay? So just opposite. So those are two types of circulation, right? In the lung, both systemic and pulmonary. Okay, now we'll talk about the covering of the lungs. Your lungs are covered by a double-layered serous membrane, which is a connective tissue membrane. How many layers? Two, double layer. Outer layer is called the parietal pleura, and inner layer is called the visceral pleura. So basically, your lung has two layers. One layer is directly attached to the surface of the lung. That is the inner one, attached to the surface of the lung. And then there is another one, that is the outer one. So two layers. Outer one is called parietal layer or parietal pleura, and inner one, which is attached to the lung surface, that is called visceral layer. Okay? So two layers. So that's why we say pleura is a double layered serous membrane. Now you see there is a space in between outer and inner, right? That is called pleural cavity. Pleural cavity. Okay? This space is very important. A fluid is present in this pleural cavity, and that fluid is called pleural fluid, which is a slippery fluid. Okay? So you see when your lung is expanding and contracting, right? 24 hours, right? Changing the shape. So when the lung expands and contracts, these two layers move like this in opposite direction, okay? Like this. So just think that if that fluid was not present there, what would have happened? Friction, grabbing, right, between these two layers, and that would have caused sharp pain during breathing. Make sense? But that fluid is lubricating the surface, right? So reducing the friction. Make sense? When the lung is expanding and contracting, the pleura are moving in opposite direction like this, and that fluid is preventing the friction. Make sense? So you don't feel the pain. Now there is a condition, clinical condition, that is called probably some of you have heard pleuritis, also called pleurisis. This is the condition where inflammation of the pleura occurs, and that inflammation causes pain. When the person breathes, these two layers move, and that causes pain. So pleuritis or pleurisy is, pleurisy, S-Y. Pleurisy or pleuritis is the inflammation of pleura. Very simple, right? Inflammation is itis. You know, all of you, that meningitis, right? All itis indicates inflammation of that particular organ. When you say meningitis, inflammation of meninges, right? Covering of the brain. Conjunctivitis, tonsillitis, pharyngitis, laryngitis, nephritis, hepatitis, right? You can say 100. So inflammation of that particular organ is itis. So when inflammation of pleura occurs, that is called pleuritis, also called pleurisy. And that is a painful condition when the person breathes, sharp pain is felt. Okay. Anyway, so also in pleuritis, the membrane secretes fluid, more fluid here. So the amount of fluid increases in pleural cavity. Okay. So that is a clinical condition. Okay. So 2 layers in the covering of the lung. Okay. Mechanisms of breathing or respiration. Respiration has 2 events, inspiration and what? Expiration. Also called inhalation of air and exhalation. Right? The 2 events of respiration. So we'll see how inspiration and expiration takes place. So respiration has 2 events. One is called inspiration, which is an active process. That means energy is required. Okay? And another is expiration or exhalation, which is a passive process. Okay? Which is what? Passive. No energy is required. So, inspiration usually takes about 2 seconds. Okay? And expiration takes longer, will be 3 seconds. Okay? Total 5 seconds. Okay? Each cycle of respiration takes how long? 5 seconds. Okay? So how many cycles in 1 minute? Okay, this is the math. Is that right? She said 12, right? 60 seconds, right? So if you divide by 5, 12. So that is the normal average rate of respiration. We said 12 to 16, okay? The normal rate. So in infants, if you see the respiratory rate, it is higher or lower than adults? What do you think?
Higher.
Much higher, right? About 40 per minute. It's much higher than adults, right? As we get older, from infancy, then childhood, right? The rate, then adulthood, and rate goes down. And in adults, it is 12 to 16 per minute. 12 to 16 cycles per minute. Okay. Now, to understand the mechanisms of breathing, you have to understand a couple of things very clearly. That will make it easy for you to understand. One is a rule, very simple rule. Air moves from high to low pressure. So high pressure to what? Low pressure. Okay. This is a rule. Okay. Another thing, if you understand, your lung is like a rubber bag. So this is a rubber bag, and this is another rubber bag. Okay. Now, if I put, for example, 50 milliliter of air here in this, okay, make sense? And 20 milliliter of air in this bag, same sized bags, okay, rubber bags. So the pressure is high where? This one, right? Make sense? Because air is more here, so pressure is high because this is air pressure. Now you tell me another thing. If I make this bag bigger, expands this, but same amount of air is here, okay? Now the bag is bigger. The pressure goes down or up? Down. Is it clear to everybody that if you put same amount of air in a smaller container and in a larger container, the pressure is less in larger, right? Is it clear to everybody? Make sense? Same amount of air. Okay, so if you understand that, now you tell me, lung is like a rubber bag, okay? So if I expand the lung, okay? The air is same amount of air inside it, okay? If I expand the lung, the pressure will go down. Is it clear? If I squeeze it, the pressure will go up, okay? So this is pretty simple. Okay. So if you know those two things, one is air moves from high pressure to low pressure. And if you expand the lung, the pressure goes down. Make sense? So these two things, these two rules, you need to remember. Okay. Now you see what happens. Inspiration or inhalation. Why air moves from the atmosphere into the lung, from outside to inside? That is inspiration. Why that happens? You see here, your lungs are here, right? Inside the thoracic cavity. So, you have respiratory muscles. Not all thoracic muscles are respiratory muscles. Remember, some thoracic muscles are respiratory muscles, some are non-respiratory muscles. Some are for the movement of the body parts. Okay. For example, you have pectoralis major, a big muscle here, that is attached to the humerus, right? That helps to move the bone. Make sense? It is not related to breathing. Okay. So, what are the respiratory muscles? Two muscles are the most important respiratory muscles. One is the flat muscle here, that is called what? Diaphragm, right? Is here. You know, separates the thoracic and abdominal cavity. So diaphragm, and I mentioned that your lungs are sitting on the diaphragm, right? Remember that? The base is attached to the diaphragm. Okay. And that is one muscle. Diaphragm is a flat muscle, okay? Respiratory muscle. Another is the intercostals. Inter means what? In between, right? And costal indicates ribs. So the muscle in between the ribs, right? Like this. Intercostal muscle. So those two muscles are the main respiratory muscles. Is it clear? Okay. Now we see what happens. When the diaphragm contracts, remember this is important, when diaphragm contracts, diaphragm moves downwards. Okay? So contraction of diaphragm moves it downwards. And another thing, how about intercostal muscles? When the intercostal muscles contract, they move the ribs forward and slightly upward, like this. This way. Okay? Is it clear? Okay. So now you see here, this is the lung. Okay? And this is the diaphragm. The lung is sitting on the diaphragm, attached to the diaphragm by fibrous tissue here, very strongly attached. Okay. And this is the front of the lung, anterior surface. So your ribs are here. These are the ribs. And intercostal muscles. Intercostal muscles between the ribs. Is it clear? Okay. Now you see, when diaphragm contracts, it moves which way? Downwards, right? And when intercostal muscles contract, this way, forward and slightly upward, right? Okay. So now you tell me, when diaphragm contracts, since the base of lung is strongly attached to the diaphragm by fibrous tissue, when diaphragm moves down, it pulls the bottom of the lung downwards. Make sense? So this way the diameter increases, the length of the lung increases, right? Pulls the bottom. And when the intercostal at the same time muscles contract, the lung is attached to the chest wall, inner surface of the chest wall, the pleura, parietal pleura, outer layer is attached. Okay. So what happens is, see, when the ribs move this way, the lung expands anterior-posteriorly. Make sense? It pulls the lung that way. So the diameter increases both vertically, superior-inferiorly, and anterior-posteriorly. Right? So both ways the lung expands. Make sense? Now you tell me, I just told you before, if you expand the lung, the pressure inside goes up or down? Down. So negative pressure is created inside the lung. Make sense? Negative means what? When you say that term, use the term negative inside the lung, compared to what? You have to compare with some another pressure, right? That is the atmospheric pressure outside of the body. Okay? So now inside is negative, right? Less than atmospheric pressure. Is it clear? So air will move which way? Into the lung. Because what is the rule? Air moves from high to low, right? So since now the pressure inside the lung is low, the air will move from outside of the body to inside. That is called what? Inhalation or inspiration. Is it clear? Now after inspiration, next event is what? Expiration, right? What happens after that? No muscles are working in this phase because this is passive, right? This is passive, so no muscle activity is needed. Now, after the lung expands, remember this is important, the lung is highly elastic. Lung is what? That's why I said rubber bag, right? You can expand it, and when you remove that pressure, you know the elastic things, right? You can expand it by pressure, right? You use in your clothes, right? Elastic thing. You can expand it by what? Pressure. But when you remove that pressure, it goes back to its actual shape, right? That is called recoiling. Recoiling. So your lung is highly elastic, lung tissue. So it can expand as well as recoil. Is it clear? So when it expands, the pressure inside the lung goes down, becomes negative. Is it clear? So air from outside of the body enters into the lung from high to low. Now you see lung starts to recoil. When the muscles relax, no more active, right? Contraction. So lung will go back to its actual shape, right? That means it will recoil. So pressure inside the lung will go up or down? Up. When it gets smaller, right? So pressure inside the lung gradually goes up, right? And when it will be more than outside of the body pressure, then what will happen? From inside, the air will be pushed outside, right? To the outside. So that is called what? Expiration. Is it clear? So that is the basic mechanism of inspiration and expiration. Just two things, if you remember those two rules, it will be easy for you to remember. Okay, just quick review. So two muscles are right, are the main respiratory muscles. One is here, that is called what?
Diaphragm.
And here, intercostal. When diaphragm contracts, it goes up or down?
Down.
Down. That pulls the bottom of the lung down. So lung expands vertically, right? Superior inferior. Now let's see the intercostals. When intercostals contract, move the ribs forward and upwards, right? So the lung expands this way. Make sense? Anterior-posteriorly. So that expansion of the lung creates negative pressure inside the lung. So the air gets it. Right? That is inspiration. when lung recoils, when the pressure muscle contraction is gone, lungs recoil. So pressure inside the lung increases, so acceleration takes place. Okay? Okay, now we'll see another thing. We now know that air moves from high pressure to low pressure. Three pressures work here. This is your lung. So inside the lung, the pressure is called intrapulmonary pressure. This is one pressure inside the lung. Intra means what? Inside. Pulmonary means lungs. So intrapulmonary pressure. Okay. This pressure changes from 759 to 761 millimeter of mercury. This is the unit of pressure. Okay. And you also remember there is a pleural cavity. Remember that? Between parietal and visceral layer. So intrapleural pressure. That is another pressure in the pleural cavity. This pressure is 756 millimeter of mercury. This is fixed. This one is not changing, always fixed. This one is changing from 759 to 761, just 2 millimeter of mercury. Okay, but changing all the time. And another pressure is outside of the body. And at sea level, the pressure, atmospheric pressure is, that is called atmospheric pressure, which is also fixed, 760 millimeter of mercury, fixed. So only which pressure is changing? Intrapulmonary, right? Other two are fixed. Okay. Okay. Now you tell me, if inside the, when lung expands, everybody, when lung expands, the pressure inside the lung goes down. So goes down to 759. Now we compare, you see 759 inside the lung and outside is what?
760.
So 1 millimeter higher here, right? So the air will get in. Okay. Now when the lung recoils, pressure goes up to 61. 1 millimeter higher here, right, than outside. So that will expel the air to the outside. Is it clear? So you see that just 1 millimeter of mercury pressure difference moves the gas, right, from one compartment to another. Only 1 millimeter of mercury pressure difference. Make sense? Okay. Now another thing you see here. Intrapulmonary pressure is fixed and 756, right? And inside the lung, intrapulmonary is this, right? So this is less or more than this? Always less. Even intrapulmonary, when it is 759, this is less, right? Here. So around the lung, the pressure is always what? Less. Is it clear? Always less. So this intrapleural pressure is very important to keep the lung expanded. Just think that if this pressure goes above 61 here, if that doesn't happen, if that happens, then what will happen? Lung will not be able to expand because outside pressure is more, right, around the lung. If around the lung the pressure is higher, lung will not be able to expand. So we'll keep the lung collapsed, will not be able to expand, okay? Which is not desirable, right? We don't want that. So the lung should expand. And this negative pressure is very helpful to keep the lung expanded. Makes sense? Prevents the collapsing, right? Prevents from collapse. Okay, so you now know how many pressures? 1, 3, right? One is inside the lung, that is called intrapulmonary pressure, which is fixed or changing? Changing. Outside of the body is called atmospheric pressure. At sea level, it is always fixed, 760, right? And in the pleural cavity, the pressure is interpleural pressure, which is always fixed, but less or more? Less. That prevents the lung from collapse. Is it clear? So, these 3 pressures are important. Now you see here, if someone inserts a knife through your interstitial space, right? Stab someone, and the knife tears the pleura. A hole is created here, right? And outside of the body pressure is what? 760, right? So inside is 759, 56, right? 756. So immediately what will happen? Lot of air will get in from 60 to 56, right? Air will get in. Now around the lung the pressure is high, right? So the lung will not be able to expand, right? That is called pneumothorax. Okay? Pneumothorax. Air accumulation in the pleural cavity and increases the pressure there. So lung will not be able to expand. Is it clear? Okay. Intrapulmonary pressure is also called intra-alveolar. Same thing. Because we know that inside the lung you have what? Millions, right? 100 millions of alveoli. So basically lung is heavily filled with alveoli. So intrapulmonary means intra-alveolar. Inside the lung or inside the alveoli, same thing, right? Okay. Okay, now that's the mechanism. Let's see next. Surfactant. Surfactant is a fluid and it is like a detergent that you used to clean your clothes, laundry, okay? And this surfactant, this fluid, reduces the surface tension. Reduces the surface tension. You see, the surfactant, the fluid is attached to the inner surface of the alveolar wall, like this. Lines the inner surface. And it reduces the surface tension here. That means just know that keeps the alveoli open. Without surfactant, the alveoli will not be able to expand, will stay like that. Since surfactant reduces the surface tension in the wall, the alveoli can expand and squeeze. Now, I mentioned in last class, right? Infant respiratory distress syndrome, IRDS, right? Lack of surfactant in infants. Now, lack could be due to what? Lack of gene, absence of gene that produces surfactant. Hereditary, absent. So if someone doesn't have that particular gene that produces surfactant, then that surfactant will not be secreted from type 2 cell, right? So that is a dangerous situation, right? Also, we see IRDS in premature infants. The surfactant cells are there, but not yet mature. Make sense? So two different things. One is absent, right? Will never be produced. Another is, since the baby born premature, those cells are there but not yet functional, right? Not yet mature to secrete surfactant. So in that case, if you take care of that baby, when the cells will get mature, right, will produce surfactant and will be fine. Okay. So anyway, so those are two types of two conditions that can cause IRDS, infant respiratory distress syndrome. Now, we'll talk about few clinical conditions. Related to the lungs. One I have already